For this video, I'd like to continue our discussion of multiplying fractions. And as we learned in the last video, the process is to just multiply straight across in the numerator and the denominator. So 3 times 5 is 15, 4 times 6 is 24, and then we would see if we could simplify this. And each of these numbers is divisible by 3, and so in effect we're just dividing by 1 and not changing the answer. And so when we simplify this, we get 5 divided by 8, or just 5/8. But let's see visually, at least, why this is true. So let me first start with this fraction, 5/6, and we're essentially going to take 3/4 of that fraction. So let me draw that really quickly. So recall that the denominator tells us how many equally sized pieces we want to split our fraction into. And the numerator just tells us how many of those pieces we actually have. So in this case, out of these 6 pieces, we actually have 5 of them. So let me just color these in green here. So this right here is representative of the fraction 5/6. And now we want to take 3/4 of this fraction. So again, the denominator tells us how many equally sized pieces that we want to split our fraction into, and the numerator tells us how many of them we actually have. So for each of these 6 boxes, I'm going to cut each of them into 4 equally sized pieces. And then out of the ones that we actually have, these green boxes, we're going to want 3 of those 4 pieces. So let me quickly divide each of these boxes up into 4 more pieces. So what you can see now is that each of these 6 equally spaced boxes that we started with, separated by the purple lines, that each of these boxes has now been cut into 4 equally sized pieces. And so out of these 4 pieces in each of the 5 boxes that we actually have, we now only want 3 of those 4 pieces. So for instance, in this first block, we have it's cut into 4 pieces and we want 3 of them. So let's just take the first 3, 1, 2, and 3. And we're going to do the same thing for each of these 5 green boxes out of the 6 that we started with. So let me do that. So now visually, you can see that when you start with 5/6 and you take 3/4 of that, what you end up with is all these yellow shaded boxes. So to actually solve this problem, we need to count up how many total boxes we have. So remember that we cut it originally into 6 equal pieces, and then each of those 6 pieces were cut into 4 equal pieces. So 6 times 4 is 24, so you're welcome to count them yourself, but basically what you'll find is that you end up with 24 pieces. And now, to find our answer here, we need to figure out how many of the yellow shaded boxes we have. And it looks like we have 5 sets of 3 shaded boxes, so that would be 15 pieces. So in essence, we ended up with 15 of these yellow pieces when our total shape was cut into 24 equally sized boxes. And we saw that answer over here, which we could then simplify, dividing the numerator and denominator by 3 to get 5/8. So hopefully this visual method of at least explaining why the answer is what it is makes some sort of sense. But in practice, we just need to remember that we need to multiply straight across. So if you don't feel comfortable with just memorizing this yet, I would spend some time actually drawing out several problems. But once you feel good with drawing these out, then at that point you can just remember the process. So let's go through a couple more examples and we can stop there. So for our first example, let's do 5/12 times 20 over, let's say, 31. And one thing you can always do, like I said before, is just multiply straight across. But if you want to simplify your answer ahead of time, what I would recommend doing is essentially looking diagonally across and basically asking yourself, can you find a common factor in each of these numbers? So 5 and 31 are not divisible by any numbers other than 1. So we can look diagonally at 12 and 20. And what you can notice is that 4 divides evenly into both of these. So before we even do the multiplication, you can divide them each by 4, changing this to a 3 and this to a 5. And now we can go straight across and get 25 over 3 times 31 would be 63. And when we do this cross simplification, and assuming that we simplified as much as possible, our answer will come out simplified as much as possible. And it's just easier to do it this way rather than to try and simplify it at the end. 5 times 20 would be 100. 10 times 31 would be 310. And then 2 times 31 is 62. So that one would be 372. And just looking at this one, it's a lot harder to identify that this is divisible by 4. And for other examples, this will be even more dramatic. So let's look at one more example here. Let's say that we have 14 over 25, and we're going to multiply this by 75 over 28. And again, you could just go straight across, but these numbers are fairly large, so it might be best to look diagonally to see if you can make any simplifications. And notice that 14 and 28 are each divisible by 7, so you can divide them each by 7, making this a 1 and this a 2. And then looking diagonally the other way, 25 and 75 each share 25 as a factor. So dividing them each by 25, we get 1 and 3. So then when we multiply straight across, we just get 3 halves. And you might be wondering, why can you look diagonally across? And it essentially has to do with the fact that you can change the order of multiplication, and it does not change the value of the result. So we know that we're just multiplying straight across when multiplying these fractions, so 25 times 28. And since we can change the order of multiplication, it doesn't affect the answer. We can just, let's say, just switch the order of the top one. So 75 times 14 over 25 times 28, and then re-separating them into two fractions. 75 over 25 times 14 over 28. Now it's like you're starting with these fractions by themselves, which you can simplify before multiplying. So again, we know that each of these are divisible by 25, and each of these are divisible by 7. They're each divisible by 14. So dividing them each by 14, you get 1 over 2. And now going straight across, you get 3 halves again. But ultimately, the reason why we can look diagonally is because we can change the order of multiplication without changing the value.